Welcome back. This is Sachin again. So in today's session, I will be covering a very basic Go application. The idea is like not go into more details that what is Go. There are pretty much articles around that. But basically at times I feel like there should be some basic project with all the current operations. There should be a database. There should be a controller layer. There should be a use case, or if you compare with the Spring Boot project, like kind of a service layer and DAO or repository layer, so that like anything which you want to try out, you don't have to spend time to basically wire up those controllers and then entities in the database. This should be something very quick so that you can try out your own stuffs. So basically that's the intent. I have already created similar video on the Spring Boot. All these links, whatever we talk in this tutorial, I'll be putting in the description. So feel free to check to that. And eventually towards the end of this session, I will also covering the rate limiter. So basically how to secure your APIs from some kind of a DDoS attack where somebody is like pumping up too many requests to your app servers, and basically how you can safeguard to just block or deny if a person, basically the source IP person or machine, is not authorized to make any specific request more than X number of times per second or per minute. So once I cover my basic, later I will be covering the rate limit as well. So please feel free to check that. So let me share my screen. Okay, keep it down. All right, so this is my project, and this is there in Git. As said, all the links I'll be putting in the description. But this is pretty much a very simple Go web project, which you can check out in your local IDE and just run it. Your all controller use case repository layer will be already created with some simple entity object and database. So let's quickly go through. So this is my main file. Okay, so which you can run. There are some paths, like sample paths I've created. So basically, this is a like REST endpoint where you can get all the employees. Let me first cover my model object. Okay, so first see the structure, the command, the CMD folder. It contains a main file which you can execute. So this is your main function, right? Config. So basically to run your project, very simple configuration I have come up with your server and the database. So basically I'm using Postgres. So you just put all information about your database, like host port, username, password, and the DB name. How to bring up the database, I'll cover it later. It's just one Docker command. As long as you have a Docker, no problem. And your server host, you're looking, you'll be running this project in 81 port in your local host. So similar to this config, you need to create a config object, the Go file. Super simple. I generally prefer to keep both of them together. I find it very convenient. So basically, whatever your YAML file is here, just create a similar structure over here. So the top layer is your AppConfig, stands for application configuration. Inside that, you have a database with a host port, username, password, and the server with host and port. Do remember all these things, the variable names are supposed to be exportable, which means you can use throughout your application. So don't make it in lowercase. The first letter should be caps so that they're exportable variable. All right, container. This is very important. I'm going to cover it a little later, but for now, just understand that this project, which has interface, the use case layer, the repository layer, everything needs to be wired. So basically, some kind of if you compare it like one-to-one comparison with, let's say, Spring project, as a service layer, repository layer, they're like they work as beans. So basically, the services, there should be a singleton instance this guy just wires all these dependencies, weave them together, and basically make it available throughout your project basically. So I'm gonna cover it a bit later. All right, now the employee object. For this tutorial, I just keep this model object very simple. My employee has only an ID and a name, ID being integer and name is a string field. So now the idea is basically we have to provide the REST endpoints for CRUD operation for this employee. So basically there will be some kind of a use case layer. Basically, if you are coming from Java background, think of it as a service layer and a repository layer, which is nothing but a DAO layer, or some people call it like DAO layer as well. So you can do some kind of database operations. More or less, I'm just exposing a few methods, like you want to save an employee object, you want to the same employee struct, you want to save an employee object, or you want to retrieve it by an ID, or basically find all the employees. Right, so this is an interface. All right, now you will see an employee folder. So basically, in the good practice, like what I found is basically within a model object, once you create your model here and define the interfaces, the implementation should be defined in a folder with the same name as you have a Go file. And here you have you'll see these two folders. One is for use case and one is for repository. Now the use case is basically considered a service layer, I said. Repository is the same thing, but a DAO layer which actually talks to a database, and the use case layer talks to the repository layer. So let's see the use case. So just come up with any naming convention. I find UCase underscore employee, that basically a model. If as and when you have more models, keep adding your models over here, and the similar use case for them, and then repository. I'll come to that later. Use case. You see the interface here, use case. This is an interface, and we need to provide an implementation for that. In GoLang, unlike Java, the implementation is not direct or very much visible, but behind the scene, it weaves, it associates that direction. So basically, as long as you have this interface, you just create a struct. Okay, this is internal to this class only. That's why I have not exported that. Now this use case implements this interface, and how it does that? Super simple. Just provide this kind of a function where there is a reference. This is an object with reference for this use case, and as long as you give the implementation for all the methods in this interface, Go understands that this struct actually implements that interface. So it's that simple. It may look a little complicated, but this is actually simple. I'll repeat once again. You have this interface, you have an struct, there's no direct relationship anywhere, but as long as by using this kind of a naming convention, you just function and then provide a reference, and just give the implementation of all these methods which are present in this interface. That's it. It will be like extending that, implementing that interface. So you see in this my ID, I can actually go to and fro from interface to real implementation layer and vice versa. Now, if let's say, for example, as I said, like this will be considered implementing that interface if you provide the implement for all the methods, which means if I comment out one method, which means now it does not even implement that. You see all this linking has been gone. So just want to emphasize on that fact. All right, now the repository. Because as I said, use case will be calling the repository. That's why you give the reference for that. How and this is the another convention, how you want to inject that dependency. So how this will get the reference for that object, because you're not calling it from outside. The good thing is like basically call with a new method. So just define new, employee use case and pass this reference, and you call it once in your whole project. I'll show you, remember that container. I'll come back to that later. From there, I'll be calling this method. But for now, just understand this is the only entry point as long as the injection of this dependency is considered. Right? You pass this repository layer and assign it, create a new instance of this, assign this repository, and then it will return a reference for this class which implements these methods. So now our job is to make sure that this method is called once and only once in your project. How we guarantee that, we'll come back when we cover container. But for now, it's just like you expose this method, make a call to this, it will inject that dependency, and that's it. Never call this method in your project. All right. So now we cover the use case. Now let's see the repository. All right. Now inside repository, I have also created a Postgres folder. Why? I'll explain that. And then this is the naming convention which you follow. And as long as you follow your conventions, should be fine. This is my model x.go file. If you understand that, this is UK case underscore x and this pg underscore x. So that way. All right. So now if you understood how I explain the use case layer, it's super simple to understand that as well. So similarly, this interface, it defines 3 methods. In my PG, you just define a struct. There's no direct connection between them. And as long as you define this struct reference over here and give the implementation, Go will internally understand that this interface implements that interface. Similarly, I just quickly want to say that if you just uncomment that out, which means one of the method is not implemented, which means this struct or this object is like not, I'm sorry, for object is like, I'm just comparing with Java. Basically, so this struct does not implement that interface. I'm gonna uncomment that. Okay. Now, again, the same thing. You are not exporting that, which means this cannot be defined from outside. This is the only one way to define or inject the guard dependency is by calling this method. This should be called only once in a project. How it is guaranteed to call it only once, I'll cover in container, but for now, just understand. You make only call to new employee repository, pass the DB object, and that's it. This dependency will be created. Now you can call all these methods from outside. All right, so now the question is why you say there employees here and why I've kept inside the Postgres folder. The reason being that currently use case is calling this repository layer and all these methods. So basically it makes a call to this guy, I mean, which you can see from here. If I call here, it basically comes here, which is inside the Postgres folder. So this use case makes a call to this repository layer. Think about tomorrow we implement some kind of a caching in between. And from here, you just want to call not the direct database, but some kind of a caching layer, let's say Redis. You create a new folder directory, Redis here, and provide the same implementation under the same method names. And then you make a call to that layer. And if the object is present in that layer, return from there. Otherwise, from there, you make a call to Postgres. So basically, it keeps things very modular, very much organized if we implement that way. All right. So I hope model is pretty much clear. Now let's come back to my container. All right. So from my main file, the only one method, I'm just creating a new instance of my container, and the only one method I'm calling is wire my dependency, which means this is the place where you're going to weave all these dependencies, and that's it. You make sure this container object is passed everywhere, and from that you just get that dependency. I'll quickly show it how. So in the container object, you define all these configurations. Before that, let's see what is the configuration. So basically, in my project, I'm like, let's say I'm listening to a port. So I have shown you like, these properties, let's say 8081. I'm listening to this port, and this I get from the configuration file. Again, as it from this C, you can get all the configuration, the application configuration, or some other dependencies. So you have to go to container. Let me cover this method first, and then I'll come back how you have to call it. So, so this container contains all these properties, the configuration. Initialize is a Boolean variable which tells whether this container object has been initialized or not. If it is not initialized, initialize it only then. If it is already initialized, just ignore that. And the use case layer. So let's see how we populate this AppConfig. So AppConfig, yeah, this is the AppConfig. This is a private method you can relate with Java, so it doesn't get calls from outside of this package or this file. So first create the AppConfig, which is nothing but this object, and get the current working directory. And basically my folder is structurally sample Google project. I'm gonna just put it over here from the present working directory, reach to the path of this YAML file, use iusual, read that configuration, and then just use YAML.marshal and fill up this config object and return it, which means whatever configuration you define over here, as long as you have given the proper variable over here, it will work out of the box. So for example, my key, and I give my test key. Okay, let me give a proper naming convention. So my test key, and in the configuration, I just need to give my key, and that's a string. Perfect, and it will basically do that. Okay, now coming back to the container. So remember, from the main file, I am just calling wire dependencies. So what it does, initialized. If it is already initialized, just return it. You don't have to initialize it. So we talked about that we will be calling the new object for use case or repository, and we guarantee that we will not call a second time. It's because of this object. If it is already initialized, don't initialize anything else. Okay, if it is not initialized, just load your configuration. Load configuration we have already seen, which means it will go, touch base with this file, and then it will load all the configuration. This config object is populated. You assign this variable, and that's the time where this variable is not null. Similarly, now we talked about get the other dependency like use case and repository. Now it's gonna do is this wire dependency, we make a call to use case, c.get employee use case. What it does, if it is nil, it makes a call to new employee use case. Remember, we talked about it's called only once. It's because of this line. If this object is nil, then only call it. The next time, if for some reason, if somebody is even calling 10 other places, you can say, okay, get me employee use case, get me employee use case. If this is null for the first call, it will create that dependency, assign it to this variable. Next time, it just return that dependency, which means this will be called only once, not even second time. The same way in the use case layer, remember, I have to give this repository as a dependency, and that's where you call a new repository layer, and there you pass the database layers. The GOM DB object, and this DB is same thing. If it is null, you just create this connection, which means you, okay, this is hard coded, but ideally it should be coming from this YAML file. I'll be fixing that later. For now, just understand, like, you can give this JDBC URL, and if there is no error, just return that connection, which means next time, if somebody from this object or from outside the this package makes a call and say, get me DB, it just return the same connection which is already created. All right, so I think this is the basic structure. We are good to go. So what I'm gonna do is, okay. Okay, sorry, sample. I'm gonna remove that project, so delete everything, and let's check out fresh code from here, from the dev branch. Get clone. Okay, my bad. I should have preferences. Font. Let me increase some font. Okay, let's keep it 16. Should be better. All right, let's clone that. All right. Okay, I hope it's a little visible and better. So, okay, we have understood these wire dependencies. Now the another part is like exposing some kind of REST endpoints. So let's say my employee's REST endpoint. If I'm just calling a root handler should handle that. I pass this configuration. Now remember, you just create it once. Now you keep passing it some other place, and any dependency you want, just ask that container c.get db or get use case layer or whatever. It will make sure that you get a same object. It does not create anyone. All right. So from this container object, I mean, this is straightforward. The max many places will find how to basically expose your endpoints. And if I make a get call my employees, it comes handle get. If I, let's say, make a post call and let's say pass my employee object, it'll save that. Not just going into too much of detail, you can go through the code, just showing only one thing, the get call. And then that's it. From the container, I say get employee use case. So anywhere you just blindly call get employee use case. If it is not nil, if the first person is calling, which I have already called at the time of wire dependency, it has already populated that, which means next time, anytime, number of times, or anywhere you call, you just return that object, not go and execute this line. Okay. All right. Once you have that use case, you just say find all employees. The same interface we have seen, the same implementation we have gone there. It will just delegate that to repository layer. Repository layer will come here, find all employees. This is pretty much create a model of employee object as an array, and then db.table, find the employees table and put the response and just return it. All right. Perfect. So once you get all the employees, just write it into your writer object so that it is visible in your curl command or in your browser. So let's run it. And the main run. Okay. Looks like database is not up. So what we are gonna do here is we will go to the README file. So in the README file, this will just, so remember, it has an model. A model has an employee object, which is an employees table, which has an ID and name attribute. And this is pretty much, I'm gonna set it over here. So again, it's super simple. The first is like bring up the database. All right, so I usually use this command. Okay, I'll quickly show you what I did. While clear, just this command I'll put in the description, but just pretty much just doing docker ps and sleeping for 4 seconds. If you have seen my previous videos, I usually use this command to basically see how many containers are running at a particular time, and there is no containers running over here. All right, let me run this container. So it creates a Postgres database with username Sachin and password this, and the MyDB, and see my container is coming, which will be refreshing every 4 seconds. All right, all set. Now my DB is created, but my employee table is yet not there. So the second thing is all the commands are super handy. Just basically blindly copy, put it, enter. What it does, nothing, straightforward. It executes, goes inside that container with the username and password, what you have already given over here in the local host, and that's it, you're inside that. /d if you put it, or /l, you'll see some information over here, but we don't have to do much. We just need to create an employees table with ID and name with this information. Just copy, paste, enter, your table is created. Perfect. Now, go to main. Okay, let me quickly debug it. Okay, I think, okay, because I checked out afresh. Let me do my key. This is my test key. Okay, and then this is a string. Sorry, not here. Key string. Perfect. And then in the container, we had the load configuration. I just gonna put a debug point over here. I just want to show you that, you know, just as once your project is there, you just check out that project, just randomly put your configuration, adjust in your config file, and your key value will be populated. Just put a debug. All right, this is my config. All right, my key. Okay, how about other information? Okay, nothing has come over here. This is super interesting. Then why this is happening? Because I did something. Load configuration sample. Okay, let me try once again. Debug. I see some problem with this guy. Sample go projects. Sample. sample copy value. Okay, this is my key. I can read that. What is the problem then, Marshall? Database config database. This is strange. Database server. What could go wrong? Sample YAML file. This is my key. Should be okay. Container. What is my file? Well, translate it. Sorry, I unshared it. What could go wrong here? Sample Go web project. Sample Go web project. config.yaml, which means it is able to read this file. Okay, let me remove it. It should not affect it though. Okay. Main file debug. So this is able to do it. Okay, I'm going to run this. Let's give it some time to breathe. Okay, interesting. So this time debug config. Perfect. I have absolutely done nothing. Just restart my ID. Maybe there could be some problem. Anyway, let's do it. My key, and then that's a string, and then my key. This is test key. All right, let's quickly test it in .go debug it. Perfect. Let's go here. Okay, my key, localhost debug. My key hasn't come. database. This is strange because it is in the okay, because it should be in the database. Okay, database server, and that's the same level. Database server, the same level. Is this a space causing problem? No, should work, right? My key debug. Database my key. Server port has come. Is it even taking this or not? 8085. Debug. This is so crazy. Type AppConfig database server. Okay. This is test key. Okay. All right. So I think we know the problem. This you have to specify that what key you have defined over here with this way. Anyways, so at least you got the idea. Like we can come up with our own key, and that configuration will be read. All right, let's run this project. And now you have a script over here. The base URL I have defined localhost in 8081 port. Why? Because this is what I have given over here. Okay, 8085. So for timing, let me change it to 8085. And this is the script I've created. You can just take the path over here and run over here. So this tells how many employees are there currently in the system. Of course, there's none. Basically, if you see, it just prints a command also what I'm executing. So it's just get command with localhost 8085, the support we have given, and the employees as a relative URL. And how it does it, basically just take the app base URL and this slash employees and point I'm calling. So this is string, I'm just equaling that to string and executing in a shell with the -c option. So I can provide the string command as a parameter. All right, so before that, let's execute the save file. Everything is super easy here. So we just comment it out and just uncomment the remaining three commands, which save employee, the Sachin A, Sachin B, and Sachin C. It comes over here and just execute this string. It echoes that, so you can actually follow what's happening. So I'm just gonna call the run script once again. It makes it call 3 times. Sachin A, Sachin B, and Sachin C is created. Now I'm gonna comment it out once again, and I don't want to save any more employees. I just want to see the same command previously I was doing. So remember, this command it executes. You can call that a string or just directly call this command. So so far so good. We are just able to check out the project, and by absolutely doing nothing, when in the README file, pasted some commands to basically bring up our database, and that's it. Run this project. Now by this time you have a full-fledged Go web project ready in your local environment, which has your controller, your model layer, your database, and your repository layer. Okay, so far so good, but there is a little problem. So we talked about rate limiter. So basically, let's see what I mean. I can make a call, and actually I can keep calling very frequently, right? So I'm executing this /employees endpoint many times. So this is like I'm just pressing my up arrow and entering it, and it's going there, getting me the response. Somebody can script it and bombard that. How to stop it? So basically, rate limiting is a solution. We need to put something, some configuration, so that we keep counting that from a given specific IP. The number of requests should not be more than some X number. And how we can do that? So you guys might have already observed. I just opened a project for reference over here. I'm not going too much of details of what I've written over here, but just want to showcase that how simple it is, or how quick it is, that you can restrict your endpoint so that nobody can call from one given IP more than n number of times this endpoint, and that is defined by you. So let's follow the README. It's super simple. So the only thing you need to do in your Go project is these three basic configurations. So I'll explain them one by one. Add below to your configuration file. So basically you have to take this and put it in your YAML file. Let's do that. So YAML file. At the last, I'm going to put it over here. What does that mean? This tells that define your Redis, where your Redis is installed, the host and port, and what rate limit you want to put. So for example, this is an array key rate unit. Key tells what URL you want to restrict. So in my case, it is employees, because this is what I'm calling from here, right? This is employees. I want to restrict this endpoint, I want to limit. How many times? So for our testing showcase purpose, I'm just putting this number 3. So I want to restrict this URL 3 per unit. And what is unit? You can define. So right now, minute and second is supported. I'm just putting a minute. So basically, in 1 minute, I should not be, like from any IP, nobody should be able to call it more than 3 per minute. And if it calls more than 3, it should result into some kind of an error. All right. This is an array. You want to keep this, or you want to keep more and more endpoints. You want to safeguard them. In my case, it's only one, so I'm just deleting it. Even if I leave it open, there is no problem. It will work even. Okay, so this is my first configuration. Let's see what else. Okay, so how about this one? Because you put all these configurations, you also have to adjust in your config file. Let's put it over here. And you need to import it as well. So import it. Okay, fine. So you put this YAML, you're adjusting your configuration. So from the config point of view, it is fine. Remember, you put a Redis configuration as well, which means in this host, which is your local host, Redis should be working. How Redis should be working, it's not the scope of this session. I will put a link for my infra project. You can actually go here, base URL, base root, and there's a project. It has a YouTube video below. Follow that instruction, but it is as simple as just like going here and executing that script in your MacBook. All right, let's come back. In my case, I have already put a command, so my container is running. You just follow that link, and this is a shortcut. I'm going to run Redis in my system. My Redis is up and running over here. Okay. Execute. I'm just going to Redis container, and I see there is no key present over because it's a brand new Redis installed over here. Perfect. So 2 configurations we have done. Let me see what else. Rate limit. Now the lastly, which endpoints you want to safeguard. You have to just call the validate method on this rate limit. So basically, in my case, the employees is handled by this handler. We need to do something over here because the request is coming and I need to validate over here. It complains about this one because your imports are not set, just go and put it in your imports. That's it. All right, so now this does not complete. Now what it does, super simple. It reads your configuration. Remember the rate limit, the new you put over here, and the YAML configuration you put over here, where you define all this configuration. So this is library. I mean, this is just library you included, and which depends on the configuration defined by you in your project, right? It doesn't have any configuration in this project. It's basically externalizing that configuration. You put this configuration in your project and leverage this library to basically do the rate limiting and safeguard your endpoints. All right. So yes, so what these simple few lines are doing, it just validate the rate limit. You pass that information to the library. What internally it does, it keeps a count that per minute, that URL, whatever configuration you have defined, is 3 per minute. It should not exceed more than 3. If it exceeds more than 3, it just blocks it. This library is not very much mature to basically uh, define the other rate limit flavors, or basically throttle it, hold your request and give the response when it is back. It just throws the exception if it is exceeding that count. So probably if in future I find more time, I will be enriching this library, but for now it's just like I spent a few hours to create this project. It's very basic, but at least it conveys the purpose. All right. Okay, and inside that, if you see, you can follow that. We don't have to know the library in depth, but just for your understanding, if I do not pass that configuration, it just complains about all that. So basically, if I remove this information, for example, if I remove it, it will complain. I'll show you. I'll let it be commented. Okay. Okay, it validates that. So I was here. It validates that I'm also, and keeps a count of it. It calculates your IP, gets your IP, and do the calculation based on your configuration. If this value exceeds your threshold, it throws this error. Otherwise, it just keeps a count in some bucket. And then I'm printing it like store the value into Redis for bucket, this one. Okay. Right, if there is an error, I just send a 500. It's up to you, whatever you want to send. I'm just for showcasing it. Feel free to send any error code, and then I'm just printing it as a response that validation is short reach for this URL. Let's see how. Let's see it in action. So perfect. My project is started, but this time this has hopefully safeguarded our endpoints. Okay. So, sorry. Oh, no. This should work, right? 805 reply from server. Why? Because host, yeah. Okay. So this configuration is working. We remember we have commented that out, uncommented, because it does not find Redis host. If you put the Redis host and then comment the other thing and then run your project, that this time the error will be different. Okay. It says rate limit properties not present. So basically, it will force you to put the right properties. Now you have defined your properties. Now let's restart. Let's clear it off. All right, my project's here. Let me clear buffer. Okay, once, 2, 3. And you see this value 1, 2 is keep incrementing it for this particular minute. If you call the 4th time, you get the validation threshold reached for this URL. It won't let you hit anymore from your IP address because your threshold has reached. So you need to wait for some time for that minute to pass. Meanwhile, we are waiting for that. I just want to show you what's happening in our Redis. Docker execute -it Redis keys system. Remember, the keys was empty. Now what it stores is, you can follow the library, but for an IP address separated by underscore and the URL pattern which you have provided, it creates a bucket. So it calculates the number of seconds, the epoch, and divided by 60 because you have given the unit at 60. and there it maintains that count. Um, Key get sorry, yeah. So it once this count has reached with your threshold, it doesn't allow any more requests. I'm sure like this 1 minute has been passed. So let's run it again, and you still see get the response. Now for the next minute, it calculates the 54 was there. Now the 455, it keeps calculating it. Now second, three has reached this time will block. Now you cannot call it anymore because it has reached to 56 by the time. Yeah, no more. All right, so I hope you have enjoyed this. We covered a lot of things over here. If you are already working in Go, many things you will be already aware. But again, the intent of this session was not to basically tell more about Go, but basically to have a project which you can quickly check out. It's a matter of a minute or two, and basically rate limit and secure your APIs from DDoS attack. Thank you.